2 on the very, very end, which was the difference quotient, right? And the difference quotient I related to you a few times, especially right here at the end of class yesterday, in the beginning of section 12.3. The difference quotient relates to slope because technically 2 f of x values are 2 y's and h is a change in x. So h is how far away 2 points are. I can actually kind of zoom in on this picture, but this is my h. H is how far horizontally apart 2 points are, aka delta x, which is why it goes on the bottom of the slope formula. And then my delta y, well, if you know that this is an x value right here, then x plus h would be right there. And so f of x is this y value, and f of x plus h is this y value. And if you subtract the two, you get your change in y's. So f of x plus h is that guy's y. F of x is that guy's y. And so when we subtract, we get our delta y. So literally, the difference quotient is like a formula for slope. Slope between 2 points. But we're not trying to find the slope between 2 points of a graph. We're trying to find the slope at 1 point. So homework actually, and the section actually starts off with, okay, so we want this tangent line, but we can't necessarily do it easily because we need 2 points, not 1 point, when we're trying to solve. Oh, sorry, my arrows are all over the place because something got changed in my settings yesterday. Trying to help me out, it just makes things a little bit harder. What can I do? What can I do? What can I do? What's going to happen to the projection? It's going to get, if I move it forward, it gets smaller, but it gets smaller higher up, and if I move it back, it's going to get bigger. So either way is not going to help. I get the idea. See? Now it's even worse. And now it's even worse. See it? And now I don't remember where it was. Yeah. Okay. I got it. I can use these arrows. I can't use those arrows. Hold on. Nope. Okay. Fine. Thank you guys for being patient. Sorry, settings got changed. They were trying to make it so my monitor doesn't black out anymore. If you guys ever see my monitor black. No, I didn't want that. Okay. No. Okay, hold on. So, how do you find the equation of slope, guys? Delta y over delta x. How do you say it in words? Remember the words I've been using all year? Rise over 1. Rise over 1. So, question. How much do you rise, seemingly, according to what they showed, how much do you rise to get to the line? 2. And how much do you run? 1. So isn't that just going to be a 2 over 1, seemingly? So n is equal to 2? Oh, so tangent lines are easy. All you got to do is draw it and then approximate it. Well, yeah, but is that very precise? No, because we said we could use our writing utensils as a tangent line, right? Just stick it to the curve. There we go. But wouldn't some people stick it like that, and some people like that, and some people like, right? And then what if it didn't perfectly hit at another nice point in the crosshair? What if it was like a fractional point? Well, then what do you do, right? So this isn't the ideal situation, but in homework, they're going to give you some graphs and say, eyeball it, what do you think the slope is? So you guys are going to approximate, well, how far up and how far over to get to a nice point. And this nice point, 3, 2, seemed to kind of hit in the crosshairs. Well, and they were super obvious in the sense of, oh, look, over 1 and up 2. Anyway, so that's just visually eyeballing a tangent line. But as we just said, that's not where we want to stop. So then we start generalizing stuff, like with the difference quotient that we already talked about. Average rate, we talked about back in chapter, 1 maybe, when we talked about slope. Average rate and slope are the same thing in the sense of slope between 2 points and the average rate. We talked about it being f of b minus f of a all over b minus a. But now we have this difference quotient that even generalizes it more and says, you know what, I don't even need 2 points. All I need is 1 point and a how far away. I don't even need 2 points anymore. I just need 1 point, like a point of tangency, and how far away to get to the second point. So we've been working with this tangent line idea for a couple sections. We've been working with the difference quotient since section 12.2. And I've been starting to apply it maybe a little bit early because our book decides to kind of go into depth here in section 12.3. But haven't you guys already seen in the preview to calculus last Friday that the way to get secant lines cutting through curves hitting 2 points, secant lines closer to tangent lines, is to make the points closer together and closer together and closer together, right? If we can make the secant lines get closer and closer and closer together, they are theoretically quite far off. Here's the tangent line-ish. The secant line's pretty far off, right? But if I was to go just a little bit closer, like this one shows, well, all of a sudden, it's going to be closer. And then if I was to go even closer, like the next one shows, it's going to be even closer. And what's happening to h as these points get closer and closer and closer? H is how far away it is. H is getting smaller and smaller and smaller, and hence H is approaching. Hey, that's what we've been doing, right? H is approaching 0. The points are approaching. The secant points are approaching the tangent point. So, tangent slopes. Define slopes of any graph, not just slopes of lines that have constant slopes, but slopes of parabolas and slopes of cubics and slopes of sine curves and slopes of ln's like we saw yesterday. We're not going to learn how to do all of them. Right now we're just going to learn how to do polynomial or rational functions. We can use the following yellow box. The slope m of any graph f at a point x and f of x. Which, to be honest, I don't like as much as, well, no, that's okay. That's okay. I want you to take out the word the and write any at any point x f of x. And I want you to write the slopes, plural. The slopes m, plural. So the slopes of the graph of f, only lines have one slope. Every other graph has multiple slopes. So the slopes m of the graph f at any point x f of x is equal to the slope of its tangent line and is given by the limit as h goes to 0 of all the secant lines, which means the limit as h goes to 0 of the difference quotient, provided the limit exists. The definition of the slope of a graph, how to find the slope of a graph. I'm going to have you put slopes, if you guys don't mind. Maybe make that one plural too. I get what they're trying to say by making it singular, but a parabola has lots of different slopes. Any curve has lots of different slopes because they have lots of different tangent lines. I'm going to freeze the screen for a second because I think there's a yellow box coming that's very similar to this. Okay, you guys have it? So what if I was to have you do the following example? which says, find the slope of the graph. Let me unfreeze it. Find the slope of the graph. Okay, so we're supposed to find the slope of the graph. We just wrote about the slopes of a graph. Find the slope of the graph at the specified point, then use a graphing utility to confirm. Number 13 gives us the following function. G of x is equal to 4 over x. And the point is 2, 2. Now, hold on. This says the slope singular. Are they wrong? No, because it says at a specified point. So there's only one slope at one point. There's only one tangent line at one point, right? Now, if I move that point, there are lots of different ones. Okay, so how are we supposed to find the slope of the graph at the specified point? Well, let's start with how do we find all the slopes? Let's go general, start general, and then move specific. So guys, how do we find all the slopes of a graph? Didn't you just write down a box? What did it say to do? You just wrote down how to find the slopes of a graph. Slope of the tangent line, how do you do it? Okay, hold on. I can tell that we're a little confused because maybe we need to highlight the most important part. Oh, I went forwards instead of backwards. There we go. The most important part of this page was right here. This is the formula for what to do. All the rest is the words of what that formula means. Okay? So this whole yellow box, yeah, it's all important. Yeah, it's all important. But the most important part is this formula right here. So how do you find the slopes of a graph? All the slopes? Plug into this formula. And then if the limit exists, booyah, I got them. You got who? All the slopes. Okay. So if they want us to find the slope at this point, let's start by finding all the slopes. How do we find all the slopes? We plug into, what's that formula? But I don't have an F. Can you apply? G. G prime. Prime. That's that word. Good. G prime of x is equal to the limit as h goes to 0. Keep going. Of G of minus. Didn't we learn yesterday how to do this? Sweet. So how do you plug in the difference quotient for that function? What would you guys do? First, you would write limit as h goes to 0. Remember, it's like not writing a square root from one step to the next. That's bad. Okay, so how do I do g of x plus h? Come on, we all did it in whiteboards yesterday. So then we need to do 4 over minus all over. Okay, now what did you guys do yesterday when we saw something similar and it was kind of tricky? Common denominator is one way of thinking about it. My trick is multiply top and bottom by both little guys, right? That's just my trick. We could also get common denominators, put it together, and then solve from there. Kyle, go ahead.
So after this step, when we start combining, and you want us to rewrite the limit as h breaks.
Every time it's a unit. Let's just do it this way. Because I'm saying something, but I'm not sure it's making sense. If I was to say something like, find f of 9 given the square root of x plus y is equal to 4. Something like that. I don't know. Maybe it's a little bit too easy. Here we go. Let's do 2 plus. Okay, if I want you to find f of 9, maybe you would start doing some work, right? Trying to kind of get stuff. But you would still write the square root the next time, right? Because you haven't done anything with it. And maybe you would start getting rid of the square root. Or maybe you would say, wait, 9, haha, I can plug him in. You would still write the square root, right? You have to. You would only stop writing the square root when you dealt with it, right? You're not allowed to stop writing things in an equation, in an expression, until you deal with them. That's exactly what I'm saying when it comes to the limit. Because the limit is like a square root in that it has a meaning, a purpose, and operation, right? So we're going to keep on writing limit until I've dealt with it, until I've plugged in h is 0 and gotten an answer. Cool. So it's time to multiply, and if we multiply, did yesterday help at all? When we distribute, what cancels or reduces? The x plus h, and what's left? 4 and x. Minus, when I distribute here, the 4 is there, the x reduces, but what's left? And then at the bottom, don't I have an h and an s and an x plus h? Now, we're going to just distribute. We're hoping stuff cancels and I can reduce. So 4x minus 4x cancels out. I have negative 4h all over hx, x plus h. How are we doing? 4x minus 4x cancels. I get negative 4h over hx, x plus h. I'm still writing limit because I haven't done it yet. Like a square root, I don't just stop writing. The h's reduce, right? There goes my whole. Bye-bye. It's removed. And now I can say negative 4 over. Wait, why is the limit gone? I'm plugging in h is 0 because I just removed what was making a problem the whole time. So I'm going to get, well, x plus 0 is x. X times x is x squared. I just found g prime of x, which stands for all the slopes. That's why I had you make it plural. All the slopes. Wait, what slopes? All the slopes to the curvy dude. Well, but they don't want all the slopes. They say find the slope, singular. So take the formula for all the slopes and say, oh, I just want when x equals 2. But y equals 2, 2. Okay, cool, I don't care. Oh, just x equals 2? Yeah, that's all I need. Okay. So I want g prime of 2. I want the slope at x equals 2. Does that make sense how we're changing? Yes. So this is all the slopes, and then if I want the slope at 2, okay, plug in 2. So negative 4 over 2 squared. Isn't that negative 1? Oh. Now, how could I use a graphing calculator to confirm? Gavin, go ahead. What's your question?
No, I was going to try and answer.
Oh, yeah. Go ahead. What do you think?
You could, you go to y equals or whatever, put in 4 minus, x, right? The original one.
Oh, 4 over x, yeah.
And
You can
then,
do that. See if my webcam's working yet. Okay, so let me come over. Let me get my graphing calculator out. So I'm supposed to go to y1 and do my 4 over x?
dang, is it
No, that's good. So now I'm going to get my curve, yeah?
Yeah.
But how do I double check? That's my curve. How do I double check that negative 1 is the slope of the graph at 2, 2?
Which one you said?
I can go to 2, 2, right? Can I go to x equals 2 on my calculator? Can I eyeball like my pencil or something coming up to it? Does that confirm?
No.
No. How do I get the line with the slope at negative 1? Just graph what? How do you just graph slope, though? Can you just graph slope? But if I graph that, isn't that a horizontal line at negative 1?
1 times x is what
Oh, negative 1 times x. Wait, why times x, Tony? Uh-oh. It is a line. It's a line with a slope of negative 1, but why isn't it hitting my curve where I want it to hit? You don't just plug in a slope to an equation of a line. Don't you also need to plug in a b? But I don't know the b. All I know is, what's the form of an equation of a line that I've been saying all year would be most helpful? Because we're going to have Random points with slopes. Ah! What form? So Tony was on the right line. He was going along the, there you go. Along the same lines of what we were supposed to be doing, except he was just plugging in the M, but we don't know the B. But what do we know? We know the 0.22, right? Point slope form. If we plug in our point with our slope, then won't I get a proper line? So that's going to be +2, +2, +4. I can make an equation of the tangent line as long as I have the point and the ding, 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 slope. So now let's see if this one skims where I need it to skim. And according to my, I don't know, people saying, I'm hoping that's good, but let me go ahead and do the +4. Does it skim at the point 2? Woo! 2! What do you guys think?
Wait, how'd you get to, what? How'd you get to solve together?
Oh, you want to do it together? Sorry, that's a mode. We use it in BC. You can have it graph sequentially, one and then the other. There's the curve, there's your line. In sequence, one and then the other. Or you can have it graph simultaneously, graphing at the same time.
So lit.
So, is this a definitive one? No. But is it pretty good? Yeah. Do you guys want to see one other thing that we can do to check? Can you guys go to your second trace button? You're not going to totally know everything. Wait, we've done value, we've done 0, we've done min, we've done max, we've done intersect, we've done... Who's that? dy dx is calculus stuff, and not just any calculus stuff. D stands for differential, stands for derivative. I can hit dy dx for this little curve that I have, and I can type in, wait, what x am I at? 2. I can say, hey, what's my slope? Dun, 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 dun. The -1 that I just found.
Whoa.
Maybe there's another way to check the answer without even graphing the line, because now we saw in our calculator there's something called dy dx. Yep. Oh, sorry. Highlighters don't like it when you draw curvy. Oh, I didn't mean to hit save. Well, this will take a little bit. Yep, just wait for it. Okay. I'm just going to come up to the board and stop trying to write from over here. dy dx. You could also use the dy dx feature in your calculator, but you have to type in, like with value, type in the x that you want. Okay, so what did we do? We wanted to find how many slopes? 1. At how many points? 1. But where did we start?
All slopes.
All the slopes, and then once we found all the slopes, then we could go ahead and plug in 2 and say, I found this slope. But that's not the only way to do it. There is a way to go straight there, but before we do the way to go straight there, hold on. Can we go back to this page real quick? And where it says definition of the slopes of a graph, can I have you guys put this in quotation marks, slopes of a graph, put it in parentheses, slopes of a graph. And I'm going to say definition of the derivative. Because slopes of a graph is a description of the guy whose definition this actually is. This is known, or somewhat known as, the limit definition of a derivative, or the limit process of finding a derivative. The limit process or the limit definition, meaning there might be multiple definitions, but this is the limit process or the limit definition of a derivative. So slopes of a graph is the idea, which is why I wanted us to start there, to find the slopes of any graph. At any point, I find the derivative, the general derivative, which has an x in it, and if I need to make it specific, if I need to go to one slope, I can always plug in x. So while we're talking about derivative, here's a couple more things about derivatives. The derivative, described as. Now, the yellow box is the definition. What are these? Descriptions, right? Definition and description. Definition and description. Are they the exact same word? Oh, yeah. We know this, right? English? definition, defining something is very different from describing something.
Whoa.
Right?
I learned more than that.
Description versus definition. So description, oh yeah, okay, well that has something to do with it. I mean, some shows or exposes or relates, identifies some part of its characteristic, but description and definition is very different. Definition fully encapsulates. Description just points to a certain aspect. So a derivative could be known as slopes to the curve, slopes of tangent lines. Could be known as instantaneous rates of change, aka, let me see if I can get a gray marker real quick. Aka rate at one point or time. Up to this point in math, we were asking for rates. We always had to give you over a time interval from here to here on average. What's the rate? A derivative says, no. Right here, I can tell you the rate at this point at this time. I don't need to do an average. So then, guys, if the directions change just a little bit, and it said, oh, find the derivative of f of x equals 3x squared minus 2x. Oh, no, the derivative. Pause. The derivative is just the slopes, and didn't we just find the slopes of another guy? Before finding the specific slope, we found the slopes. So when it says find the derivative, it's really just saying find the slopes to the curve, aka use the definition of the derivative to solve. So this one, do I need to plug in a point at the end? No. I'm just going to go ahead and say I want f prime of x, and that's it. So the limit as h goes to 0 of f of x plus h minus guess what? That's what we were doing yesterday. Right? So weren't we doing difference quotients? And then we were simplifying, then we were taking a limit? Oh, so they just put new words in there? Yeah. So we're going to be solving the limit, guys, that we did yesterday. So you guys know you're going to be simplifying, right? Maybe some of you want to do some research tonight as to how I can very easily say that 6x minus 2, dun, 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 without doing any further work in the limit. But for right now, I'm just saying, how would you solve this? FOIL it, distribute it, combine like terms, take out an h and plug in. The rest of the h's are 0, and you would end right here. Maybe you want to look up shortcut rules to derivatives as to how else I got there. But for right now, technically in homework, you're getting really good at the limit, because remember, yesterday I showed you an AP multiple choice question that had a limit in it that you had to interpret. So limits are super important. But so far, okay, well, hold on. This one said find the slope at a point. We found all the slopes, and then we plugged in. This one says find the derivative, so I just needed to know that just meant find all the slopes, so I get to stop here. I don't have to keep going. So what's this last page of yellow boxes for? Wait a minute. What's this last page of yellow boxes for? You don't need that one. We've already talked about that one quite a bit. In this section, for some reason, the book kind of like restates itself over and over and over again. There is a formula for finding the slope, like we just did a second ago, without having to go general and then specific. There is a formula.
C's, Devin. I just said that different.
It could technically be f prime of C, or you could say f prime of A. This one says, what if you want to go straight to the slope and not go through all the slopes first? You guys kind of get what I'm saying? Going straight to the answer of the example 2 examples ago instead of having to do the all slopes first. There is a way to do it. Sometimes it's useful and sometimes it's not. But what it says is use the difference quotient, but in lieu of the general x, put the specific c. In place of substitution for the general x, which would lead us to all the slopes, go straight to the specific c. There is a way to do that. not always helpful, especially if you have to find multiple slopes and you're going to have to redo the process over and over again, as opposed to knowing all the slopes and just plugging in x's at the end, however many you want. But there is a way to do it. So if you did want to find the slope at this point using this formula, you would say f prime of -2 equals, wait, why -2 and not 4?
4 is the y.
4 is the y. We want the x. And then I would just set up my difference quotient with limit as h goes to 0. But instead of f of x plus h, I do f of -2 plus h minus f of -2 all over h. Then I would go to my function and plug in. So I get the limit as h goes to 0 of -2 plus h squared minus -2 squared all over h. The limit as h goes to 0. I'd have to FOIL this guy out to get 4 minus 4h plus h squared minus 4. -2 squared is positive. I would simplify. I would be able to reduce away an h. And I would solve by plugging in 0. But do you guys see how I never got my general derivative? I never got the equation with x's. I went straight to the slope, straight to the answer. So there are multiple ways of getting to a specific slope. Sometimes in homework they're going to say something about use a particular formula. You might have to go back into the book, into the section to figure out that they're talking about this formula. They just want you to get to know it a little bit because it can show up on, wait, we saw one yesterday with the nasty ln and the e squared. It was like this. Bye, cool kids. Start homework tonight. Come tomorrow with questions. Might do a couple more examples. Oh, yeah. Could you go back to the...
Trying to be like that. Trying to be like that.
Chapel day, chapel day, chapel day.